Welcome, everybody. And I will start to thank Domitile for being with us for this Digimedia Innovation Circle. This time, I would say that we will have the pleasure to have Domitile sharing with us a work that I already had the pleasure to see from another keynote on the digital summer school in Greece, and I think this work is very well connected with some of the activities on Digimedia, because we will be listening a work that has something related with training, with education, also with virtual environments, and some parts that are a little bit more advanced on the technical part that related what we are doing in our research unit related with this orchestration that Domitile will share with us. But I will pass the word to Domitile. Domitile, thank you very much for being with us.
Okay, thank you, Carlos, for the invitation, and hello everyone. So I will speak about narrative orchestration-based virtual environment for training. So I'm working in the Heudiasyc laboratory. It's a joint research unit between University of Technology of Compiègne, it's an engineer school, and the CNRS. And I'm working in an artificial intelligence team. I am the coordinator of the specialty artificial intelligence and data science at the computer science department, and I'm vice president of the Artificial Intelligence French Association. So my purpose today, my motivation are to improve virtual environment to train to manage not only normal situation, but also degraded, stressful, critical, or crisis situation. And in this situation, there are no ideal solution. I'm trying to train not only technical skills, but also non-technical skills like situation awareness, leadership, team working, stress management, or decision making. And the situation must be controlled, adapted, and personalized. So how to train to crisis situation management? We would like to operationalize the constructivist training. That is to say, we want to confront the trainee to a large variety of situations. And we need to orchestrate the virtual environment. So what is a crisis situation? It's a complex social technical environment which has undergone sudden changes, like after terrorist attacks. The situations are particularly stressful and they are difficult to reproduce. And the stress is the main cause of operation failures. It's difficult to target which stressors are the cause, and the interpretation of physiological signals is difficult. So why we want to personalize the situation? All trainees are different, and it is necessary to adapt the training to each profile according to their ability to manage their stress, the elements that cause the stress, and their ability to learn. So we need to create many situations in order to target their difficulties and to work on them at the trainee's pace. So I will illustrate my purpose with a use case, the victims project. We want to train a medical team for casualties rescue in a mass influx of casualties after terrorist attacks, military fightings, or natural or industrial disasters. And we want to train the medical leader, and his team is played by virtual characters. So As you see in this video, the trainee is immersed with a head-mounted display, and he has to prioritize the victims. He can act directly on the victims, but he can also give orders to his medical team. Sorry. So the existing approaches to orchestrate virtual environments for training. You can have pure simulation without pedagogical control. But if you need some pedagogical control, usually you have scripted approaches. You have to write all the alternatives. So it's a huge work to find all alternatives, and usually the trainee has to find the right solution to continue. So you don't have a user agency and you don't have trial and error processes. So you can use interaction graphs to give more alternative between plot points, but we have a problem of scalability, and we need a huge authorial work. To give more adaptivity, you can have some semi-autonomous characters, which are resilient and adaptive, which have adaptive behaviors. But when you want pedagogical control, you need to give them some orders. And when you give orders, you lose in coherence and in explicability on their behavior. And you can have autonomous characters, which provide more adaptivity, but it's difficult to have a pedagogical control in this case. And at least you have generative approaches with planning techniques. And in this case, to have a generation in real time and to have a quick process, and not to have a combinatory explosion, you need to have a heuristic to find a quick solution. And in this case, the solution is not the best pedagogical solution. So you can lose in authorial intention. So can an orchestration system provide user agency, control, coherence, and adaptivity? Because we have traditional oppositions between user agency and pedagogical control, called the narrative paradox, and between control and adaptivity, called the authoring bottleneck. So to balance these constraints, we propose to couple a generative approach with planning techniques for the scalability and adaptivity, and an emergent approach with resilience for the resilience and the explicability with autonomous virtual characters. So we have virtual environments. We have a world manager to manage all the behavior of the object in the virtual environments. We have autonomous virtual characters, and these characters can have personality, emotions, stress, and they can have erroneous behaviors. We have a learner monitoring to monitor what the trainee is doing in the virtual environment and if he is doing correctly or wrong. And we can have some physiological sensors to measure his stress, for example. So how to direct the scenario events in a personalized and in a relevant manner? So we propose Seldon. It is an orchestration engine which provides some adjustments on the virtual environment on virtual character without giving order to the virtual characters. And we can play on a minimum of adjustments. These adjustments can be the late commitments. That is to say, all the states of the simulation are not initialized at the beginning of the simulation, and we can commit during the simulation. For example, we can have hidden injuries, and if you want to complexify the scenario, you can add an injury or to remove an injury which is hidden. You can trigger some events like storms, explosions, or new victims. And you can force a probability of failures. For example, a difficult operation or difficult medical act. It can be credible to have a failure. So how to direct the simulation to realize relevant training situations? So in this question, we have two questions. The first one is how to select desired and non-desired situations and properties, like, for example, difficulties. So we wanted to reify the zone of proximal development theory of Vygotsky. I don't know if you know this theory, but Vygotsky say, in fact, the trainee has a zone where he can learn by himself, and around there is a zone where he can learn with the help of a trainer or with the help of technology and tools. That is named the ZPD, Zone Proximal of Development. And there is a zone where which is beyond his reach. So to reify this theory, we have several difficulties because we have imperfect data. We have uncertainties, imprecision, contradiction, and sometimes we have ignorance due to the sensor, because it's difficult to know if the trainee is really stressed or if he has cognitive load or if he has some cyber sickness or visual fatigue, because we have the same effect on the physiological data. And because we have ill-defined domains. We are not in a context of mathematical learning, for example. It's a complex situation, and it's difficult to define which kind of abilities, which kind of stressor are involved in this kind of situation. So to manage this kind of imperfect data, there are several approaches: Bayesian network, physiologic, to manage uncertainty, imprecision, and ignorance. But we have chosen a mathematical framework, the theory of transferable beliefs, because it's a generalization of these approaches. And it can manage the contradiction in the data. And we add a semantic model to allow semantic reasoning on a certain data. So we want to create zone proximal development profile. So what the trainee is able to do and what he is not able to do. So we propose to create a space which represents this ZPD. We propose a n-dimension space. Here I represent only 2 dimensions. And for readability. And each point of this space is a class of situation in which you can work some abilities under some stressor. For example, here you have to work the ability how to manage the priorities of the wounded between two children during a tempest of sand. And here you have to manage the priority of the wounded between a friend and an ally. So the dimensions are created with a taxonomy, which describe all the abilities and all the stressor. And in this taxonomy, we haven't prerequisite between concepts, because we don't know if it is more difficult to choose between two child or between two allies. It depends of each trainee. But we have a semantic proximity between these concepts, and we can have similar situation between the nearest class of situations. We also have a hierarchical space, so you can reason on the problem of meteorology, or to reason on the tempest, the kind of tempest, sand, snow, or the storm. And you can reason on the intensity of a sandstorm, for example. So then you can put the trainee in a class of situation, and you observe what he is doing, if he is doing correctly, if he is doing quickly, or is doing wrong, and how is his stress level. And then you can have some information about his aptitude or inaptitude to manage this kind of situation. And if you have not enough information, you can have ignorance. And if you have a contradictive information, you can have contradiction. So you have a sum of all these parameters, and this sum is equal to 1. Then you can have belief propagation to the semantic situation, to the nearest semantic situation. And you can have a belief revision when you have different sources of information. And then when you have your profile, you can select the next situation to work. So according to the strategy of the trainer, you can explore differently the space. And so we propose different algorithms, the nearest neighbors or the gluten algorithms to explore differently the space. The idea is to explore and to expand the ZPD space while respecting the pace of the training. So we couple a theory of transferable belief and semantic model for generative power, because we have as many classes of situation as there are combinations of nodes possible in the taxonomy. And we have a full automation of the ZPD space generation. And we can have a personalization because we have as many profiles as there are individuals. So then we need to translate the classes of situation. We have chosen to use the fuzzy cognitive maps. It's kind of scripted fragments of scenario, allowing to describe how to work some abilities to respect the authorial intention. So it's like small scripts. And the fuzzy cognitive maps, the FCMs, allow to describe causal chains on qualitative data that is described using linguistic terms to express uncertainty parameters like often, sometimes, rarely, because experts cannot tell that a medical operation might fail if the caregiver is under 10% stress. They would rather say that it might fail if the caregiver is highly stressed. So the FCMs are intelligible for experts. The fuzzy cognitive maps allow reasoning and flexibility, and to define fuzzy precondition to provide variability and explainability. Usually, the PDDL or script planners with technical planning support hard precondition, but it's difficult to model some subtleties of the reality. Here, to provide explainability and prevent scenario from incoherencies, our orchestration engine do not randomly force the result of the action without scenaristic coherence. So, sorry, maybe I can come back. Here, FCM allow to work on the ability how to manage teammates' misunderstanding. So you need to have a wrong medication preparation. So it is credible if the virtual character is unskilled. We can force the probability of the wrong preparation, but if the virtual character is experimented, it's not credible. So we need to trigger stressful events. So because the trainee must understand why some tasks fail to provide him an opportunity to react. So it is difficult without precondition to define correctly this constraints occurrence change. Indeed, the success of the failure does not depend particularly on one factor, but rather on a pondered function of these factors. So we can define here a function, an activation function. And for example, we can describe, you can have either a caregiver with no experience and no stress, or with high stress and no experience, or with medium experience and medium stress. So the FCMs can be expressive. So now we need to direct the simulation. We have chosen the training situation, the next training situation, and we need to direct the simulation. The first step is to instantiate the different script fragments, and the planner will seek to satisfy the precondition that will lead to the task failure by having a new victim who will need a medication, and by triggering a problem of light, for example, to stress the virtual character if the trainee chooses an experimented caregiver, or by forcing the probability of the failure of the action if the trainee chooses an unskilled caregiver. So after that, we need to assemble the different script fragments. Here are the fragments, the FCMs, and we need to create the events, the adjustments to prepare these fragments. And we need to plan and monitor the plot points and to trigger the adjustments. And maybe we can replan the scenario if the trainee or if the virtual characters do not act as the planner has predicted. Then, with PhD students, who is at the end of his PhD, I think he will finish at the end of the year. We would like to know how to give a more narrative concept in how planification. Because the researches in interactive storytelling show the growing tension allow to provide more flow and more engagement. So we wanted to study if a narrative structure was able to improve our scenario. But we have several difficulties because the narrative scenario must be consistent. It must increase the narrative tension, and it must be adapted to the trainee's abilities. Another difficulty is that we are in virtual reality and we need user agency. And the last difficulty is we have a medical doctrine. The medical doctrine is to avoid excessive failure. For example, the death of all patients. So we wanted to couple a generative approach with planning techniques and a narrative approach. So the narrative pattern in storytelling makes the creation of cohesive stories easier. And a narrative pattern is a description of the story according to the action and events that compose it. And there are many schemas which have been studied within the framework of narratology. So, we have studied different narrative models and structure in order to find the one that correspond to our needs. So I present you some of them. The first one and the most famous is the monomyth for the hero's journey. In this structure, a hero must face a difficult situation and he fails. And after that, he is called to the adventure. He refuses, and a magical character comes and explains him his life mission. It is the beginning of his transformation. The hero faces different challenges with mentor's help, and at the beginning he fails, and progressively he has victories and is coming wiser and wiser. At one moment he has a revelation, a real transformation, and he returns to the first situation, the ultimate adventure, and is victorious in this decisive crisis without the help of his mentor. This structure has been used in different structure in literature with Russian tales, in movies like Star Wars, Lord of the Rings, in video games like Call of Duty, Half-Life, The Legend of Zelda. And it has been used in serious games with the learner's journey. This structure was not adapted for our use case because it stages a failure, and it was not possible with our medical doctrine. Another structure is the epiphanic structure. It's a narrative structure featuring at a given moment a revelation, a twist, which causes the player to suddenly understand the events of the narrative in a different light. The structure widely used in the cinema or video games, like in Fight Club, Nier Automata, or in Sixth Sense. In our case, this structure allows to work on the sociological and psychological aspect of teamwork and the lack of information. But in fact, it was difficult to use to allow many scenarios around stress. It was difficult to find many ideas for this structure. And another structure is the Ganga comics. This structure is based on the adaptation of Indian mythology in comics, in which the solution to one conflict also immediately causes the next conflict to arise. So we have chosen the Ganga comics because the structure is similar to the chain reaction of crisis situation. We wanted to operationalize the Chekhov's gun. So the Chekhov's gun is that states that every element in a story must be necessary. For example, if a gun is introduced in the first act of an episode, then the gun will be used in the third act. We proposed to use the foreshadowing. The foreshadowing is a narrative process by which the writer uses details to suggest what is to come later. It helps the reader or the spectator to develop expectation about the upcoming events that keep the audience more invested in the narrative. For example, here in Reservoir Dogs movie, Mr. Pink and Mr. White are trying to find which member of their group ratted them out. And as you can see at the end of the wall, it's clearly visible that there are pink and white bottles, and they are separated from the orange bottles. This gives an indice that Mr. Orange is not really part of the group, and he is a police officer. So, using the previous process, we needed to provide adjustment to integrate the narrative patterns. So, after the selection of the class of situation, we need to add some nodes to each class of situation in order to create a narrative around the ability to be worked on with planning techniques. So we add some adjustments, the Chekhov's events and the foreshadowings. So for example, we can have elements that do not jeopardize consistency, and to create some announcement effects. So we can announce an explosion, we can announce an evacuation, which is called the medevac. It's an evacuation to the hospital, and so on. And after that, we need to assemble the different script fragments with the Ganga comic structure. So for example, here, the trainee has to work two classes of situation, how to manage an injection during a bombing, and after that, how to manage a medevac, an evacuation. So if the trainee chooses a victim who need some oxygen, we will create new injuries, new victims who will need some oxygen, and we will create a lack of oxygen. But if the trainee chooses a victim who needs some morphine, we will create a problem with the morphine. And we will create new victims who will need some morphine. And at least we need to plan and monitor the plot points and triggering the adjustments. A difficulty for the adjustments is to modulate, to have an increase in the tension, but we need to have modulate the level according to each trainee. So if finally the situation is too easy, we need to increase the difficulty. But if it's too difficult, we need to decrease all the situation. Okay, we have conducted different kind of experiments. The two first ones was to know if we were able to measure the stress. And the problem was how to distinguish physiological states between stress, mental workload, visual fatigue, or cyber sickness. Because and even in virtual reality, you are moving, so you can have an increase of the cardiac rhythm. So we have used different sensors, the eye tracking in the head-mounted display, an electrodermal activity sensor, and an electrocardiogram sensor. And we use a specific task, the Stroop VR. So the Stroop VR, I don't know if you know the Stroop task. In the Stroop task, we present a word. For example, here it's written yellow in blue, and you need to say blue and not yellow. So we proposed a control task with a Stroop task in VR. And we propose three kind of conditions. One dual task, you have to do two tasks, the Stroop task and to press a button when you see a red word. We had a stressful situation with an alarm at 80 decibels and a stereoscopy condition. Okay, this is a test if you want, but I have no time, sorry. So the first result of these experiments was really surprising, and because it is not, we were not able to measure the stress. The people, the user didn't hear the alarm. So maybe the mental load is more stressful than the acute stressor, and maybe the user have a behavioral strategy like a tunneling effect on non-technical skills. They are concentrated on the main task. And it is the same for because the performances were better in the dual task than in the control task. It was really surprising, but maybe the user focus on the difficult main task and are better when they have stress. Or maybe another solution, another hypothesis is that it is difficult to measure stress in virtual environment because the user are moving with controllers and in the real environment. So the results on the second and third experiments show that we have a good prediction on other cognitive states with not with the stress, but with the cognitive load and cyber sickness. And the third experiment show we have learning effects between different sessions. And on Friday, we will have a fourth experiment to evaluate the effect of our narrative structure. Okay, to conclude, I would like to present you my next works. So I would like to implement the Kobayashi Maru. It is a training exercise in the Star Trek universe. It has been designed to test the characters of the Starfleet Academy in a no-win scenario. So the trainee has to choose between to save a planet or to save his family. And the trainee, Kirk, beats the Kobayashi Maru. He can save the planet and his family by cheating and by reprogramming the simulation. But the creator of the Kobayashi simulation, Spock, is disappointed because the objective is not to win, but to have a decision, a difficult decision during a dilemma situation. So I would like to generate dilemmas. A dilemma is the obligation to choose between two parties, which both have serious consequences. You can have moral, ethical, social dilemmas. And what is difficult is to generate automatically the dilemma without describe what is a dilemma before. And so a dilemma will be to have to choose between two moral obligations, for example, to choose between two child or between two allies or between an ally and an enemy. And I would like to work on the generation of cognitive dissonance. The difference from dilemma is when you have a cognitive dissonance, all the choices haven't serious consequences. For example, you have to choose between an enemy and a child. And the doctrines say you have to choose the most urgent, the most the victims with the more gravity. And imagine the doctrines say you have to choose the enemy. But maybe you can have a cognitive dissonance if you have to choose with a child, because maybe the enemy has killed your colleagues. So it is a difficult choice, even if it is not a dilemma. But maybe for one trainee, it will be difficult to choose with a child because he has children. So it is difficult for him. And for another who doesn't like the children, it will not be difficult. And maybe it will be difficult to choose with a grandfather, because maybe he has losing his grandfather recently. So I have a new PhD students who will begin on this subject in January. And maybe next work, I would like to work on the uchrony reification. That is to say, if you choose something and you can try, what would have happened if I had made a different decision? So you give oxygen to a victim and the victim die. So you can go back and change your decision and give him more oxygen. But maybe in this case, you will not have enough oxygen if we use the Ganga comic structure, and because you can have more victims who will need oxygen. So thank you for your attention. And if you have a question, please speak slowly to help me to understand.
Thank you so much, Domitile. I think it was a great presentation about a very complex and a huge research project that you, not just a project, but the research work that you have been doing. And I would like if someone will join the discussion with a question or observation. Who will start?
I would like to say hi, guys. Well, it's not a question, it's just congratulations for your work. It's really very interesting, and it's very inspiring for our work as well, especially this approach that deals with specific types of narratives and the paradox, the narrative paradox, which is very interesting. So congratulations. It's not a question, it's just to thank you.
Well, thank you.
Anyone would like to have some questions? No? So I will have one. The kind of the virtual reality experience that you started to show us, do you have it in an environment that, for instance, if someone visits you in Paris, it's possible to try it and to, even if we are not doctors?
Oh yeah. It is possible, yeah. Because yes, so we have the stroke tests, so everyone can do the stroke test.
Nice.
And we have the third experiment was with more generic actions. We need to go on victims and to have a mental calculation, so everybody can do it, because you need to have a multiplication and a subtraction to do, and to inject a product on the victims, so it's easy to do.
Okay.
But on Friday, the experimentation will be with militaries, so you need to be a caregiver for this experiment.
So,
and if you need all the data from the sensor, the physiological data, we can share all the data on the stroke test. So if someone wants to try machine learning techniques or something like that, we can share the data.
Okay. Anyone would like to have a question?
But if you want to come in Paris or at UTC, it's at 60 kilometers in the north of Paris. You are welcome in my university.
Thank you, Mario. We should request a budget to the research unit and go for a visit.
Yes, probably in the next mobility program, probably next year. It will be great to visit you guys.
Yeah. We have facilities to invite some researcher, foreign researchers. So, yeah, if you want to come, you are welcome.
Thank you. I was also talking with Louise. We have now a master student. I think she's here somewhere, but she's doing a work trying to relate storytelling with gamification and trying to create a framework to help teachers that are creating gamification strategies to make really interesting gamification gamified activities by following some storytelling structures. And it was really interesting to see your work on that field, and I hope it was also interesting for Laura to listen to your words about the storytelling approach that you have